All right, intermediate algebra, your last con for this very short unit, 3-day unit, is called explicit formulas for geometric sequences. And just like the explicit formulas for arithmetic sequences, these come in a little bit different form. First of all, there's a form that you have not learned yet, just for exponential functions. Remember when you learned y equals mx plus b, and then I told you how the new one works for an arithmetic sequence? There is a similar formula for exponential functions, which is y equals ab to the x power. And I haven't taught you that yet. We're getting into the exponential functions coming up soon here. But that is kind of the normal way that we write things. However, for a geometric sequence, they prefer it. It's not wrong if you do it this way, but they prefer it in this one, where f of n, which means the function of n, equals your first term. Over here, a would be your 0th term, where it starts on the y-intercept. So a would be like your y-intercept or your starting point. Over in this one, though, it's your first term. And remember, all sequences start with the first term. So 64 represents the first term, not the 0th term. Okay, so when we put it into this format, okay, the 64 would go right here. B, in both of these cases, whether it's here or here, stands for your growth rate. How is it changing? And then it's to the nth power. Over here in the normal one, it's to the x power, unless they're using n for a variable, then it would be to the nth power. So let's get started. If we were to do this in the function, in the geometric sequence way, which I think is actually easier for this one, we simply go, what is our first term? Well, our first term in this one is 64, so we put a 64 here. Then you'll notice most of you will say that they're dividing by 4 each time, which is true, but they always want you to turn this into multiplication. So instead of saying you divide by 4, we will instead multiply by the reciprocal of that, or 1/4. Okay, so that becomes your b value. And then it's always to the n minus 1, because remember, n minus 1 would take us eventually back to our beginning value. So we always do this to the n minus 1 power for that one. If we were to put this, and it would accept this answer as well, if you put it into this form, you could do a different way of doing this one. And I have an or, there it is. You could instead work this backwards and figure out, gee, what would the 0th term have been? And I could instead work this backwards and multiply that by 64, which would be 256. I still have the same growth rate of the 1/4, and then you just simply do it to the nth power instead of the n minus 1 power. Either one of those works. In this case, either of these answers work. So, did this one answer it correctly? Well, he had the first part correct, which matched up with this part, but then he just had n, and it's supposed to be n minus 1. This person did not have the correct starting point at all, so that person is definitely wrong. So in this case, both of these two were wrong. Okay, let's do one more example. They will also ask you to do this type of problem. Again, this is your first term. Remember, there's 2 ways you can write this. You can do the standard way, or you can do it the geometric sequence way. Again, I think geometric sequence is easier, so I'm going to do it that way first. I'm going to take my first term, and I'm going to plug that in here. Again, we were dividing by 4 each time as we worked our way across. So, in other words of saying that is, instead of divide by 4, we multiplied by a positive 1/4. And then we always put that to the n minus 1. This would be the answer I recommend you put in here. However, if you like being difficult, and that's fine, I actually was when I was a kid too, so I totally understand. You could multiply this term by 4 and get back to your original one, which would have been 384. The b, the growth rate, still stays the exact same way, and then it's just to the nth power. Either one of those work. Hopefully you make sense of this, and I'm there to help you on Google Hangouts. Have a great day, guys. Bye-bye.